right, we're going to do some more descriptive statistics, and this time we're going to add mode to the mix. So remember, the mode is the number that appears most often. So when you look at all your data, if you have a number that repeats over and over and over, and it's there the most often out of all of them, we call that a mode. You can have two modes. We call that being bimodal. We really don't usually have more than two. If you have more than two, you just say no mode. So, okay, let's get into this. Do some math. So, I have this set of data, and it's in order least to greatest, and it says which value is the mode. So when you're looking at this, look at repeaters. 12 is repeated 4 times, nothing else is repeated at all, and therefore 12 is my mode because it's there the most often. All right, to refresh, letter B says, what's the median? Well, median is the number in the middle. So I'm going to go through and I'm going to check them off. A small and a big, working my way to the middle. A small and a big, a small and a big, a small and a big, a small and a big. I have 2 numbers left in the middle, and that means my median cuts right in the middle. I'm trying to find the average of those two. 13 plus 31 gives me a value of 44. Divide it by 2, and that means my median is 22. To find the mean, I'm going to add all of these numbers together. So when I add them all together, all of these numbers, I should get 299, and there are 12 numbers. So my mean is 24.94. Now, I recommend with your mean that you show your work, just like this, 299 over 12, because if you add wrong, if you forget a 12 or something, if you show that number, your instructor is going to be able to say, hey, Sarah, you missed a 12, and then they know what you did. They might be able to give you partial credit or something, or at least they'll be able to help guide you in a better way. So show your work if possible. Now, these are the ages of people at a show. So if you wanted to sell merchandise to people at this show, what age should you target? Based off your mode, median, mean, what do you think? Looking at your ages, right, they range from 11 to 50. So I would say, well, in this day and age, 11 and 12-year-olds want to be 30, and anybody who's an adult wants to be younger. So I would target mid to late 20s, because if you aim for 25, everybody wants to be 25, right? It was so much fun being 25. Sometimes it was fun, sometimes it was stressful, but you can probably aim for the mid-20s and you're going to appeal to a decent size audience. That is pure speculation. We could have a 4-hour conversation on that and probably still not be done, right? So answer that however you want. Let's do another one. We have some data values here, and we want to find the mode, the mean, and the median, and then talk about the distribution, whether it's skewed left, right, or symmetrical. Now, hopefully you notice, first off, that this data is not in order least to greatest, and that's the first thing you want to do. And I want to show you how I handle this. Not that you have to do it my way, but I think it's a decent way, so I want to at least share it with you. It's very easy when you're reordering data to miss numbers, to totally just forget them. So what I do is I notice that 1 is my smallest number, and so I will put a 1 and then I'll cross it out. But you'll notice that I put it right under a different number. So 2, I got rid of a 2. There's another 2. I put it, sorry, I can't write here very well. I put it right under so that they line up, right? 3, 3, 3, 3. I don't know how many 3s I have, 5. So that's what I do. I just make sure that they line up so that when I'm done, I should end right where the numbers are. Then I don't forget them. I also cross them out as I go, keep them in order, and it keeps it fresh. So that's usually what I do. Now, when you look and you're looking for the mode, what number appears most often? Well, 1 is there twice, 2 is there twice, 4 is there 3 times, but a 3 is there 5 times. So the mode is 3. Now to find the mean, we're going to add them all together and divide. So when I add all of these numbers together, I end up with 51. I divide by 15, because that's how many numbers there are, and I have a mean of 3.4. With the median, I work my way to the middle. 3, 4, 1, 2, 1, 2, 1, 1. There's one number in the middle, and the median is a 3. Right? I do the cross out, get my way in. So is this skewed left, right, or symmetrical? Well, the mean is 3.4, which is greater than the median. And if it's greater, that means it's skewed to the right. So we are skewed right because of the fact that the mean is greater than the median. When I look at the next one is a box plot. And it simply says, this is the same data we just talked about, except now it's in a dot plot fashion. But if you think about this as a graph, does the graph show how it's skewed? Well, generally you look at, this is the biggest point. Where is the tail? The tail is the longer side. Well, this side, the tail, is going to the right. So this shows that my data would be skewed right, which is exactly what we said before. So this diagram does go with the fact that we said it should be skewed right. Okay. All right, we are now going to just do some random, this is going to refresh us on some proportions, but it's good too. So, some problems dealing with sub-Saharan Africa, which I will then talk about as SSA because that's a lot to type out. So sub-Saharan Africa is home to nearly 10% of the world's population, and an estimated 25 million people from this region have HIV. So the first thing, estimate the population of sub-Saharan Africa from the world population. So we know from this that 10% of the world's population lives there. Percent over 100. And on the right side, think part to whole. The world population is 7.3 billion. Well, would the world be part or whole? Well, the world is whole. Sub-Saharan Africa is part. And I know it's billion. I'm going to add the billion at the end. So here I cross multiply, right? 100x equals 73. Divide by 100 and I get 0.73 billion. And you might say, well, I don't like that 0.73 billion, and you're right. Remember back from earlier, we talked about every 3 decimal places we have a new name. So I'm in billions. So if I would go 3 decimals this way, I would go down 1, and I would have 730 million. So we'll use that. There are 730 million people in sub-Saharan Africa. That's a lot of people. All right, letter B. There are 35 million people in the world with HIV. What percent of those live in sub-Saharan Africa? Okay, what percent? So I'm going to have x over 100. Now on this side we have part to whole. Total in the world is 35 million. If you recall from the previous, 25 million people in sub-Saharan Africa have it. So 25 is sub-Saharan Africa. The bottom is the world. Oops, I spelled that wrong. So to solve that, we cross multiply. 35x equals 2,500, and x equals 71.4%. So roughly 71% of the people with HIV in the world live in sub-Saharan Africa. Isn't that crazy in one section of the world? So crazy. Now, what percent, okay, when I see what percent, x over 100, what percent of the sub-Saharan Africa population has HIV? Well, if you recall, we know that 730 million people live there and 25 million have HIV. So we have HIV over the total, right? And I got those values from previous problems. 25 million people in sub-Saharan Africa have HIV. There are 730 total. So when I cross multiply, I get 730x equals 2,500. And roughly 3.4% of the population of sub-Saharan Africa has HIV. Now, percent out of 100. That means if you put 100 people from sub-Saharan Africa in a room, 3 of them will have HIV. 3 out of every 100 people there are infected. Letter D. In 1993, the median age of death in sub-Saharan Africa was under 5 years. So we'll just say that it's 5. What does this tell us? Okay. If these are all the people in sub-Saharan Africa who died, all of them, remember what the median is. The median is the middle number. So the middle number is 5. That means all of these people in this half are from 0 to 5, and these people are from like 5 to 100. So that means half the people who died in sub-Saharan Africa were under 5. So if 100 people died, 50 of them were 5 years of age and younger, and 50 of them were over 5. So that's really sad. That means there's just a lot of people are dying at a very, very young age in sub-Saharan Africa. Now, once children lived past the age of 5, life expectancy went up significantly. Would you say that age at death in sub-Saharan Africa was skewed left or right in 1993? Well, if we do age at death and we do the number of people that died, kind of like we did in an earlier example in a different video, we know that half the people that die are 5. So there's a lot of people here, and then it kind of goes down. So we would say, just based off the data, it was skewed right, because half the people are between 0 and 5, and the rest of the half are split up way over here. So this data would be skewed to the right. And that, my friends, is skewness mode and all kinds of fun stuff.